Hello, and thank you for joining me. You're here with data science teacher Brandon, and we're going to go over the second level data analysis project, and we're going to cover different dog breeds in the world. Something interesting to explore, and we're going to keep it a little bit simpler today. Okay, so getting started, we're going to import our data analysis libraries. Start with pandas as PD, numpy as np, Seaborn as SNS, and matplotlib.pyplot as PLT. We'll use all of these to go through our process. Okay, and what we're going to do first is, now that we've imported the libraries, we're going to go to SBS SNS. And so what we're going to do first is import our dataset. You'll notice here it's in my GitHub reservoir, so you won't need to download the dataset. You can just assign it to df is equal to, we're going to use pandas to import this, so pd dot read underscore csv. Okay, so pd dot read csv. So let's load up this dataset. Okay, so we have that ready to go. Okay. And the next step, it's always just a good idea to understand what the data types are in your data set, really just to get a good sense of how we're going to analyze this data. So you can see all objects. So we're going to have to deal with this in different ways and really understand how to go through this. It's a little bit more complicated than just objects, but we'll see how we deal with this data set first. Okay. So the first thing that I noticed is that the data set has lots of capital letters. Just to make my life easier, I'm going to put it all in lowercase. So it's just a little bit easier to copy and paste the names if I need to write or anything. I'm not remembering if I need to do capital letter or not. So to do this, we're going to use a pandas function. So we're going to go pd.series, and then we're going to put in the list of the column names. So df.column, so this is column names, a list of the column names, putting it into a series so that we can have access to the pandas functions. And so that's how I'm going to do this. Dot string is on the series that I created from df.columns. So now it's a pandas object. I can go dot string dot load. Nothing really super fancy, but now I can have access to the pandas options. Okay, so what I wanted to do here, I'm going to create a secondary data frame that we're going to do a lot of the same pre-processing to, but to enable some of the bivariate analysis, we're going to kind of keep this one separate. Okay, so what we're going to do here is we're going to go df.copy. So if I don't do copy, what happens with Python is you'll create two variables that are pointing at the same place in your memory, and when you edit one, you'll edit the other one. So we don't want to do that. So .copy creates a genuine new copy, a new place in your memory for that. So we've done that. And then just to show you how to look at different palettes, the standard palettes in Seaborn are pretty good, but the standard palettes in Pandas are not the best. So just to show you how to change that, you go PLT, so from the matplotlib pyplot .style.available, and you can see all of the available style palettes. And then to use those, you go plt.style.use, and then whichever one you chose. I chose Solar Light 2 just to have fun. Something a little bit different today. I'm just experimenting around with it. I don't know if it's my favorite, but I did. Yeah, it looked pretty good. It turned out really nice today. Okay, so in the next one, what we have, and like just to show this, so if we look at the BirdColor column, you can see it looks like a list. Technically, this is only a really long string, but we know it's a list of yellow, black, and chocolate. So we need to tell, first of all, we need to tell Python it's a list of items, and then it's not just one big long string. So after it's a list, then we can use another function to deal with this, because really, this is technically semi-structured data, right? So we have 3 items here, 2 items here. And if you think of a data frame, that's structured data. It's always the same number of columns, always the same number of rows. Even if there's null values, it's still the same number of rows. It's the same shape. Because we have changing is structured, but it's a changing shape. It's called semi-structured data, and now everything works a little bit different. So we actually have to change this into structured data so that we can perform the analysis that we're used to in Pandas. So what we'll do first is really easy to do. So what we'll do is we'll do string. So we're going to select the column .str .split, and then we're going to split on quotation marks, comma, space. So we're splitting on this right here, the comma and the white space. And when after we run this, to show you what this looks like afterwards, it's going to look almost identical, but it's now a list. And we know it's now a list, a Python list, a data type list, because it's in these square brackets. So now these are not commas anymore. They are commas to us, but what it is actually separating the positions of each item in this list. So yellow is in position 1, black is in position 2, whereas this is just a one long string with some white spaces and some commas in it, but it's just a long string. Okay. So now that we've transformed it into a list, we can deal with this incorrectly. So I just wanted to show what was happening. So we'll go df.shape, dfa.shape. It'll be interesting to track this as we go through our different transformations today. So I'm just putting dot shape in all of these going forward. So what we're going to do is we're going to print out the shape before and the shape after. We use df.explode. So we're using dot explode on the fur color, the list of items that we have now, the semi-structured list. And we're going to just assign, so we're giving it the whole data frame, dot explode, and then we're going to return the whole data frame that's been transformed. We're going to get some extra rows. What's going to happen is for this row 0, there's going to be 3 row zeros now. It's going to be yellow, and then all of the same data, and there's going to be black, and then all of that same data repeating in the rest of the row, and then chocolate, all in the same. What we can do with that, it seems like we're just creating a lot of data, and there's going to be lots of duplications in the other set, but we'll be able to still inspect things proportionately, maybe not by count, but proportionately. So what we can do now on a column that has this stuff, make sure it looks like now, in the regular form that we'd expect in a category, we can see, oh, sorry, DFO. So just noticing that I am transforming, I'm assigning the output of my explode to df0, which is, so just, we're going to temporary df that we're going to reuse over and over again. We're just going to place over it. But dfa, we're going to do this again on dfa, 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 whereas in the first one, we're just doing this on df. So we're only creating this df0 and we're replacing it. But we're going to keep doing this explode where we expand the number of rows on one other data frame to do comparisons later on. Just to not mess up our analysis before we get to that. Okay. So in the next row underneath this, we'll do BirdColor dot value underscore counts, and then we're going to do dot plot, dot bar, and then we're choosing the color palette that I have. And pal, I just assigned that to the color palette at the top right here. You can see this list of colors. It went well with the style that I chose, so feel free to choose a different color palettes. Okay. So we're going through here, and you can see this now. And okay, and right here, so we see our fur color, and we can see black, red, white are the most common occurring colors. We have lots of different, many different unique colors that only occur once or twice or a couple times. And so we can see here when we run the country of origin, I was just going to see if we can inspect it, but there really is talk because we see lots of countries of origin. There's quite a few animals that occur a very small amount of time. Okay. So then what we're going to do, okay, so then what we're going to do in this next one is we're going to do basically the same thing that we did last time. We're going to split, we're going to explode, we're going to split and turn into a list the unstructured string that we have in color of eyes, like we do in many things in this list. This is common with movie titles as well. So we'll go df square brackets. We're going to write out the name, and it's all lowercase because we made them all lowercase. Color of eyes is equal to df square brackets in a string with quotation marks, color of eyes. And then we're going to do that string str string dot split. Okay, we're going to just do the same thing that we did before, and we're going to do that. Okay, so now we use split and turn into a list the string of eyes of colors. Okay. And so then next, what we're going to do in the next one, we're printing out the shapes that we did before, and we're going to do dot explode on the df, and we're going to set it to df0, temporary kind of data frame here. And what we're going to do is dfa is going to be, we're going to go dot explode. So we're doing this again over, and we're going to assign this to dfa next time. So we're going to keep making this bigger and bigger, so we'll be able to do a bivariate analysis later on, and we'll see that at the end. Okay, so you can see here now, I started with 250 in my A data frame, and now I'm at 275. I always have 200 or 117 rows in my normal data frame, and expanded it just a little bit here to 225 or 125. Okay, so we're doing that, and in the next line, we're going to plot these. So we'll do color of eyes dot value counts dot plot, and we're going to do kind equals bar, color equals the list of palette colors that we have, and we're going to do big size equals in parentheses 10 comma 4. Okay, so there we go. And then in this one, what we're going to do is color revise. And so it's interesting to see this, but I was curious to see what percentage when I was writing my notes and stuff. I wanted to know the percentage of these. So we can do is do value counts, but we can also do normalize as one of the arguments, and this will give us the percentages, not just the counts, or instead of the counts. And you can see that gray makes up less than 1%, brown is 92%, and so on. So we have not many, most dogs' eyes are brown, which is interesting. I kind of thought that was obvious, but never really actually calculated that before. But yes, I think every dog I've ever seen, except for a couple, have been brown eyes. Okay, so we're going to the next one. So we're going to do the string dot split. So we're splitting it, just both of them, the df and then the da again. And then we're going to go print this stuff. So we're going to print these messages. Really handy just to kind of track these. So we print. Because I'm going to repeat this. I really always recommend typing things out, but print is something you're probably going to type out a lot. So I don't know if you need any more practice with that one. But it is good to build up that muscle memory. That's the goal of these projects, is to help you build muscle memory. And so what we're going to do here is we're going to df7 117 we see, and then after we expand it, 473 rows. This is a big one. So character traits was quite a few items in each list that we expanded. So we create a lot of new rows. And before we had 276, and now we have 1,113. So we get quite a few extra rows from this now. So we ran that. And what we're going to do in the next one. So this is kind of not complicated, but a little bit different than what we've done. So we can see this. So let's see these value counts right now. And I gotta finish my thing. So we're gonna go in the first none. Gotta do value counts. Oops, sorry, I'm selecting the wrong one. That's what I got. So what we want to do is select this one right here. So just to show you what this looks like. It's a value counts. We've done it for the plots up above, and you can see what it looks like here. But what we can do then is we can select, if we're going to do this value counts, if we do greater than 1, yeah, trues and falses. Now we can logically index this value counts with this logical index that we've created. So just like we would do on a data frame, we're going to take the square brackets and we're going to put inside this logical index. So it looks a little bit weird when you're doing this on value counts, but it works exactly the same as if you were to do it on a column in a data frame. So right here, so we're doing value counts greater than 1, which creates this, and we're going to use that in the first set of square brackets after value counts to select out only the true values, which means that we'll only see values greater than 1. So it's not so long. This is such a big list when I first did it. So this was just to really reduce again, so we're not just seeing the 1 count, we're listing up to 2, which is still quite a few values. We might want to do this something like, we could say greater than 2, so only 3. Let's see here. A little bit, actually, it's a little bit nicer to do. You don't really need to see all the way down to this. Okay. Okay, so going into the common health problems, so we're going to go through this and let this all finished for us right here, because we're going to go into some fun stuff pretty soon. So looking at the character traits. So everything that we saw exactly the same for these steps. Okay, but now we're going to get into height. So common health problems. Those ones off the ball were all semi-structured for lists, strings that were actually lists that we had to turn into lists and then explode to be able to do this, where we have just one item in each row, one value per row. They're both correct formats. It's just for which analysis you need to do, it depends. It can be a little bit more space saving doing it the way that they did. So it's done often that way to save space. And then as we analyze things, we have to transform it to get stuff. Here we also have maybe, I don't know if this is a space saver, but we have, instead of a value, we knew already there's an object, so it wasn't going to just instantly be ready for analysis. The height should be a number, and I thought maybe it was a symbol, like the IN symbol, but it's actually a range. Dogs do range, they don't have a specific height. It'd be nice to have an average, but we have a min and a max value. So what we're going to do is we're going to have to build something to select out the first 2 columns and then the next 2 columns. Okay? or sorry, not columns, next, the first two items and the last two items. A little bit more complicated than that because I actually found some other stuff as we were working through this. So what we're going to do is we're going to build a little function, and then we're going to use Pandas to apply this function in the next line. So this will be just allow us to kind of select out those two from there. So this is a string, so we'll be able to just index this and get the first two items. So what we're going to do here, we're going to do df height underscore min, and we're going to give it x. X is going to be the value as we're using the function down below. It's going to apply this to every row. And so the value in the row at the time is going to be x. So we're going to take out the value from the row, which is going to be height in inches. It's going to be these values. And then we're going to go if the length is equal to, because it turns out that they're not, they look all evenly here, but it turns out that they're not. Okay, so if length is equal to 5, what we're going to do is we're going to return from our function integer, because this is going to be a string of the number 13. So we won't be able to do math on it, so we're going to put it into the int so that it converts it into a numeric number instead of a string. Okay, so we're going to select the 0 and the first position, the first two positions up to but not including position number 2, the third position, just to get those two. Then we're going to do elif, and I found this out afterwards. I didn't know this right when I first built this. I ran into, but that's why I have this print here. I was trying to understand what each one of these looks like, and you see me here printing this out as well. I'll go through with you what I was seeing and why I had to do so many of these things. So elif, it's the length of 4. We're going to get the integer, and we're just going to get the first position. So 0 going up to 1, but not including 1. So we're just getting the first position. Okay, and then what we're going to do in this next one, we're going to do elif length equal to 3. We're going to go return an int, again, up to position 2. Okay, so we're going to do the same thing there. And then in this next one down below, when we do the height max, we're going to, again, do integers. So remember, this is going to be, we're selecting out a string, and then we're going to need to do, so here we're going to do int, and then here we're going to do int as well. Okay. So we're created our functions. Now what we're going to do in the next one, we use pandas function dot apply, get the height minimum, and we're going to go apply and get the height max. So we're going to apply those functions across the rows. So here's some good examples of what I was seeing. You see here that this is 4-5. Well, that was a little bit tricky for me because you see this is only 4 strings now, so we only selected the first position of this one. And then we had 3 values, it was 1-1, and so we had to do the first and just the last position. So you just had to change things a little bit into how you're indexing depending on the situations. There's usually only a certain number, but that's where this print inside the function becomes really handy. It's kind of, I might probably want to turn this off before I hand this in, but this is how I figured out how to do the if, elif, and elif statements, the logic statements. Okay, so in the next one, what we're going to do is we're going to take that column, the min height, and plot, and we're going to go kind equals as a string, so in quotation marks, we'll do hist, and then we're going to go title equals distribution. Okay. And then we get a nice little plot, very interesting to see, almost uniform, but there's a little bit of bunching up, which is kind of interesting. I don't know why most dogs tend to be more concentrated around these two heights, but maybe something to explore a little bit further and maybe ask a dog expert. Okay. So we're going to change the fig size in this one, and we're going to add fig size, and we're going to add color, and we're selecting from the palette. So we're doing the distribution of the, oops, and we got to always spell things correctly. Okay, distribution of max height. So now we're going to do the same thing for longevity. Okay. So here, leave most of this done, but remember after we're doing an if statement, so if length equal to 5 colon, elif length equal to 4 colon, elif length equal to 3 colon. Okay, so we've got it super important. You can see you actually have a colon here too, and when we define the function as well. So it's very common Python syntax. Okay, so what we're going to do here in the longevity, we're going to define def, the function name, the values we're going to pass in the function, and then the colon. And then in the next one, we're going to do return integer of the value, or sorry, of the index from the second to the last. Here we're going to return an integer term an integer of second to the last as well, and we're going to return an integer here as well of just the last position. Okay, so we'll go through all three of these. And then what we'll do here is you'll see this, we're going to now apply these functions. So we're going to go longevity min. So let's stay organized here. So we're going to do min longevity, applying this on the one, and then min longevity on the other, the AF, or DF all, DFA one that brings. So the longevity max, and then put this in apply longevity max, and then the last one, apply longevity max, and just make sure I'm applying this all in the same column, but I have the names max and max. So just make sure you're applying it to the right column, or the column you expect to be. Okay, so went and did that. And then what we're going to do, because I wanted to see a little bit of the count of these actual values, because it's a little bit hard to see here. So what we can do, just a very quick, easy way to see, is we're going to plt.show, because if I don't do plt.show, let's turn this off the first time. Colab just displays what is in the last row or the last line of a cell. So if it's not in the last line, like this plot up here is not anymore. It's not, we're not going to be able to see it. So when we do this next line underneath, value counts, we will only see the value counts, and then normalize that we see the percentage of each one of these. Look at it, proportion based, we're not going to see the plot here. So if we wanted to, it kind of works, I guess. If you wanted to see what happens here, plt.show is kind of like print this. So it's make a plot, print the plot, and then because this is a collab, I can just put the value counts in the last row and it will display that. Okay, a little bit organized. So now that we've done most of that all together, let's do that now together. Okay, so column names, min longevity. Okay, so what we're going to do is we're going to go df square brackets in a string max underscore longevity dot plot kind equals hist, title equals distribution, big size equals 4, 8. So it's 4, 8 is the width, 4 is the height, and then color equals path. And just like I mentioned up above, we want to do plt dot show to print our plot, and then what we want to do is select this column again. We want to do dot value underscore counts, and we're going to normalize, and not a capital, normalize. Get that? Next plot, perfect. And there we go. We can see it's kind of interesting seeing the distribution, but we see the min heights, and they both have the bunch activity here. It's really interesting. And then later on, because we've been keeping the df all, and so please inspect that. Go and have fun. I wanted to understand if maybe the fur color had anything to do with longevity or the height or anything. And so it doesn't look like I ran this one, because of what it was saying. Sorry, and that was just saying, it's saying name SNS not defined. I don't know how I didn't run the first column, not interpret. Okay, well, let's look at this. Oh, looks like I forgot to run a couple columns. So let's go to height. So I define those two functions. I ran them right here. Max height and height. Oh, and then I didn't do it. That's what I forgot to do. I didn't run these. I must have corrected this. I didn't run this on the DFA. So DFA. DFA. So these things happen. Sometimes we forget things. Don't like to do this in the YouTube videos, but that does happen. So let's run that again. And then what we should see now is when we go back down to the size, longevity, of color, we'll be able to have those values. And so when I saw that the column isn't identified, it should be there. So it's a little bit suspicious. So I knew it would have to be up in an issue up above. And here we get a pretty ugly graphic. So this is what we're going to finish with, but this gives us a value right here. So this is not what we want to do. So to make this a little bit, we just have too many colors to deal with. So To make it a smaller amount of colors, we'll do index here. And what this is doing to show what this looks like. And notice that I'm doing this on the DFA data frame, so the data frame that has everything in it. And so what index does is gives us value counts, and it gives us the indexes that are in the left-hand side, which you can see, which is these values right here, which are now the index values. So we go like this, to the index values. What the up to 4 is giving us 0, 1, 2, 3, up to 4, but not including this one. So this gives me just the amount of colors that I want. So I'm going to do the index to then select a list, get a list of those values. So just the 4 most common occurring values, I'm going to assign that to fur colors. And then what I'm going to do in the next line, I'm going to go S and S. This is a Seaborn plot now, so that we can use the hue argument. Right, so we'll do S and S dot hist plot. And we'll do data equals DFA. And then what I'm going to do is I'm going to do is in. So just notice here I'm doing a little bit of logical indexing. I'm doing df, square brackets, df column name for color is in for color. So is in this list of things that I just created. I'm resetting the index because the exploding that we did just created so the indexes are all the same value. So this reset index is just to avoid an error, just to show you what this looks like actually. It doesn't give you an error instantly. It almost looks like it's working. It's like, did this work? But here you can see cannot reset index from duplicated axes. And that's just because the dot explode duplicates the axes, and then exploding when it's duplicating the rows and adding the values. Okay? So this is something we do. So I just did the reset to avoid that error. Nothing big, but that's what's going on there. In this next one right here, so you can see the forecast is really kind of interesting inspecting. I wasn't expecting fur color to have a difference, but it does seem to have a trend right here. You can see red and brown, or red at least, tends to be weighted to the longer side. Blue has a good bunching up over here, so black has a good bunching over here, which would be interesting to understand why black has kind of the max height seems to be not maxing up, but seems to be running into kind of a wall here, not getting. So those are all questions for experts. Okay. So what I'm going to do in the next line, so we're doing our histogram plot, and we go underneath plt dot title. And what I'm doing here, just to note, I'm going line break n, line break n. You don't have to do this. Most people don't. I think it just looks kind of nice because if you don't do it, what happens here, it's not bad. It's a little bit squishy, I feel like, though. And so what I do is I do a line break before and a line break after. Just give it a little bit more space at top. It's kind of like a title should be, I feel like. Okay. So it's doing that, and we'll do this one more time now for the character traits. Okay. So we're going to do the same thing we did before because there's just a lot of values of this. So there's a lot of very unique values for character traits, especially. So we're going to do the same thing, index and selecting the first 4 values, the first 4 most common occurring character traits, and we're going to plot those. So we're creating character traits right here. And it's always good to type things out when it's a variable name that you're never going to use in a different workflow. I think it's better. It's okay to copy and paste it, and that way you're making sure that you don't spell anything wrong. Then what we're going to do here, so we run our logical indexing, and just like we had to do before, is we have to reset underscore the index. And this is occurring because we created so many of the duplicate values over and over. So we get something by height, and that's the max value by height now. And now let's look at longevity by character traits. Okay, and so what we're going to do here, just notice we're going to put the title, or sorry, hue, slower here, hue on longevity, and we're also going to change the color by, sorry, X is the continuous variable, and hue is our category or character traits that we're going to do. And again, we're sort of selecting a few of the character traits. And you can see intelligent dogs seem to be kind of a little bit longer here. And then the energetic dogs, I want a dog that a little chihuahua maybe, they live quite long. That's very, very interesting. Okay. And not really anything noticeable around with playfulness that you can see is really concentrated around 14 to 16. And that's why I did the KDE equals true, just because you get a lot of this overlap. So having this line can really help you determine where the distributions are really sitting. Okay. So we're doing the same thing with health problems now. And we're going to do just a couple things here. We do KDE equals true, plt dot title. explain what we're doing there. And now let's do it all together. Okay. So let's go SNS dot histplot data equals df, and then we're going to do logically indexing for when the common health problems, that column is in this list right here. So I'm going to copy the health problem name. Quite a long variable to write out. So here we go, health problems. And then we're going to reset underscore index. And we're going to set the continuous variable, the max longevity, to x. And then we're going to set the hue to the common health problems. And this is the main reason that I'm using this versus Pandas, is to have access to this hue, change the color of the categories. It really allows for some pretty interesting and quick and easy analysis. You do something similar in Pandas, just a little, quite a bit more work, truthfully. And then what we're going to do is change the bins to be 15 as well here. Okay. And then in the next one, we're going to do plt dot title. And we get a pretty cool plot. And it's very interesting. You kind of see a little bit of bunching up. The health problem didn't really seem to make a huge problem, but you see hip dysplasia is being very concentrated over here on the left-hand side, which is kind of, you get bigger dogs that have hip problems, they tend to have to be put down at a young age, so you can see this happening. It's interesting, kind of confirming what we know about real life here in this data set, but there's a lot of stuff to explore. I didn't go through all the analysis, but really interesting about dogs. Okay. So thank you for joining me today, and I will see you next time.